Hi, so welcome to another video. This is about another geometry problem. I have picked this problem because this illustrates some special identities about in radius and x radius of a triangle. Let's get to the question. It says, prove that a triangle in which root r1 plus root r2 plus root r3 is equal to root of r1, r2, r3 divided by r. This relation is satisfied. That triangle will always be equilateral. Here, R1, R2, R3 are the x radii. Okay, x radii basically means if you draw a triangle like this, you extend these sides, you bisect these two exterior angles, and draw an internal bisector like this. This point is the x center opposite to vertex A, and you can draw a circle which touches all three sides and has center at this point. So this circle will have radius of r1, right? So this is the rough explanation of what an x radius is, and we have some formulas for x radii and all. R1, R2, R3 can be given by del by s minus a, del by s minus b, and del by s minus c, where del is obviously area of the triangle and s is semi-perimeter. So these are facts that we know from basic trigonometry. If you want to know more about this, what you should refer to is it is chapter 15 of SL Loney plane trigonometry. It has a lot of these results in one of those exercises. I think it is exercise number 36 or something. So you should check that out definitely and try to solve all of those identities in exercise 36. One of the identities there we will use in this problem as well. So I'll just show you when the time comes. So let's see what this problem is. You are given this fact, right? So root r1 plus root r2 plus root r3 is equal to root over r1, r2, r3 by r. So let's bring all the x radii terms to one side. So divide by root r1, r2, r3 on both sides. So I'll get 1 by root r2, r3 plus 1 by root r1, r3 plus 1 by root r1, r2. This will be equal to 1 by r, right? I'm getting this expression, correct? Now, what do I do here at this step? There are standard ways to do it, which will be a little more calculation intensive. So what standard way I'm referring to, you can just substitute this into this result and also substitute r is equal to del by s, which is the radius of an in circle is equal to area of the triangle divided by semi-perimeter. Just by substituting them into this might definitely will lead to a solution, but I'll show you a nicer way. So what we will do it is we'll do it on the next page. So I have this result right now, 1 by root r2 r3 plus 1 by root r1 r2 plus 1 by root r1 r3 is equal to 1 by r. Now there is an identity that is proved in SL Loney. The identity is 1 by r1 plus 1 by r2 plus 1 by r3 is equal to 1 by r. Why is this identity going to be important here? And first of all, is this even true? It can be verified that it is true very easily, because 1 by r1 will be s minus a by del plus s minus b by del plus s minus c by del. And if you add all of them, this becomes 3s minus a plus b plus c, which is equal to 2s. So 3s minus 2s by del, which is equal to s by del, which is equal to 1 by r. So that we have quickly proved here, right? So this is fine. So this identity is there. So why not convert 1 by r and write it like that? We get 1 by r1 plus 1 by r2 plus 1 by r3 is equal to 1 by root over r2 r3 plus 1 by root over r1 r2 plus 1 by root over r1 r3. Now this problem is very straightforward. You can just substitute 1 by root r1 as x, 1 by root r2 as y, and 1 by root r3 as z, right? And this becomes basically xy plus yz plus zx is equal to x square plus y square plus z square. And this is a standard identity. This minus xy minus yz minus zx is equal to 0 means half into x minus y whole square plus y minus z whole square plus z minus x whole square is equal to 0. And sum of three squares can never be 0 unless each of those squares is 0. So we get x is equal to y is equal to z from this, right? So once you get that, you know suddenly that R1, R2, R3 are all equal because x was 1 by root R1 and y was 1 by root R2 and z was 1 by root R3. So if at R1, R2, R3 are equal, then that definitely means that A, B, C are equal. So the triangle becomes equilateral. This question illustrates why you need to know certain identities, certain algebraic identities about quantities connected to a triangle. And these identities you'll find very well illustrated in SL. So I recommend you guys do that exercise of chapter 15. Once you do that, you will feel a lot more confident about triangle identities. I hope you learned something from this video. I'll see you next time.